Namaste, sir.
Namaste, 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 Anushka. How are you?
Sir, fine, and what's about you?
Yeah, I'm also absolutely fine. Thank you so much. Okay. We'll wait for a few seconds, and then we'll start today's class. Okay. Let me see the number of students who are joining. So last time we discussed some terms like speed, velocity, acceleration. Speed, velocity, accelerations. Okay, let me just know, okay, what type of speed does a body possess? Okay, when it covers equal distance and equal interval of time. So voluntarily, okay, anyone
Sir,
can give
uniform.
answer.
Sir,
Very good.
uniform.
Yes, yes, excellent. Yes, excellent. Yeah. So when a body covers equal distance and equal interval of time, and it is said to be in uniform speed. Good. Okay, now please, next friends, can you tell me the SI unit of speed?
Sir, meter per second.
Meter per second. Okay, like that we have another quantity at the acceleration. Now, if there is no change in velocity of a moving body, yeah,
So
we know the
wait
body is
second
in
order.
motion. Okay, that the body is moving.
Unmute
That
government.
means it is covering distance. Let's say in a direction also.
No,
But
boss. आप
okay,
वैसे
it does not change in
मतलब वैसे
velocity.
कौन बात नहीं
So
मिस
it is moving with the same velocity, means uniform velocity. At the time, who can tell me the value of acceleration, okay, produced on that body? The condition is class 9, the body is moving with uniform velocity. Okay, when a body is moving with uniform velocity, so what acceleration is produced? Or let's say what value of acceleration will it have?
Zero.
Zero, ma'am.
Zero, actually,
Zero.
very good. Yes,
Zero.
excellent. Zero, good. Very good, zero. Because uniform velocity means constant velocity, and constant velocity means there is no change in velocity. And if the velocity does not change, then how can a body have oscillation? Because oscillation means change in velocity, right? Okay, thank you. Then class 9 today we will okay be having the class first 5 minutes. So we'll do recap of the previous topic for 5 minutes. We'll do recap review of the previous topic that we discussed last week. Okay, then after we'll connect a new topic for today. And let me tell you, class 9, the new topic that we are going to start. Okay, from today is there is a graphical representation. Okay, and two types of graph we will read. One is a distance time graph, another is a velocity time graph. Very simply, the line graph. Okay, now without taking any time, now let me start. I can see already there are many students learning. Okay, so let me teach you share some ideas about the topic by sharing the slides. You can see on your screen. Okay, here is yeah. Okay, okay. Yes, wait for seconds. The you will see okay the slides that I have shared on your screen. The last time we discussed, we read about acceleration. Let's have short review, okay, short recap on the same topic. Now, class 9, if you see, okay, the slide carefully, so you can see two pictures, one above, okay, for ball 1, another that's below for ball 2, right? Here one figure and then down and figure, okay? So in the above figure, okay, when the ball 1 is in motion, okay, initially the ball 1 had 4 meter per second velocity, and after that so for some time, okay, after some seconds, now it gains another velocity which is also 4 meter per second. Now in its point, okay, showing the motion of body, okay, the figure is showing you the same velocity at each point. Means the first figure say that the body does not have acceleration because the same velocity means there is no change in velocity. But if you see or if you observe the second picture just below this for ball 2, okay, over there you can see initially the body was at rest, okay, and the velocity was 0 meter per second only. When it came into motion, now it acquired velocity which is 2 meter per second. And after a few seconds, now it gains another velocity which is 4 meter per second. Now if you see the first two, 0 and 2, see between this you find the change in velocity. The 0 velocity, okay, reaches to 2. And if you compare the second and the third, there also you find the change in velocity. Now the 2 meter per second, okay, reaches to 4 meter per second. That means the ball 2, okay, that figure clearly shows that so it is gaining acceleration. Okay, the question is there. So here is which ball is accelerating, ball 1 or ball 2? Okay, and the students of class 9 easily can answer that is ball 2, obviously. Well, the ball 2, it is in motions by changing its velocity, okay, after certain interval. So finally, if you are asked to find even the velocity, if you assume that the time taken to cover this displacement or to change velocities once again, you can say that 2 meter per second minus 0 upon 1, you obviously 2 meter per second square. Even if you compare the change in velocity, okay, between second and third, 2 meter per second as initial velocity, 4 meter per second as final velocity, and 4 minus 2 is 2, 2 upon 1 is, that is 2 meter per second square. So between these two balls, ball 2, it is accelerating, it has acceleration, and how much acceleration is produced? Okay, it is 2 meter per second square. And one more thing I want to see here, okay, the ball 2 in figure second. So it has, what type of acceleration? Obviously, uniform acceleration, right? Because there is a equal change of velocity. Okay, from first to second also 2 meter per second, and first, second, and third is also 2 meter per second, and for third and fourth also 2 meter per second. And then if there is equal that the rate of change of velocity, okay, in interval of time or in unit time, and the type of acceleration is that uniform acceleration. So ball 2, it has acceleration. And what type of acceleration? Okay, it is uniform acceleration, because ball 2, okay, we can see the change in velocity. Now let me go to another slide. So you can see some figures there. Okay, the first figure say I'm speeding up, means I'm changing the velocity. Okay, at the time is the change in velocity increasing. So increasing velocity, okay, that is oscillation is produced. In second case also, okay, that is slowing down, means what? Velocity decreasing. Okay, there is decreasing velocity, and in second also there is oscillations produced, and in third case there is a change in direction. So whenever there is change in direction, velocity changes, right? And by the change in velocity, what oscillation produced. So all these three figures, okay, that clearly show that they all have, okay, accelerations, okay, during their motion, right? Okay. Next is accelerations. You can see. Okay. Last time, okay, I told you that I'll come, okay, with some examples of that is uniform accelerations or non-uniform accelerations. So one example you can see over here. Okay, this is for the acceleration due to gravity. Okay, uniform acceleration. See here, when that apple is just about to come into motion. Okay, just about to fall. At the time, the velocity is 0. Okay, and when it comes into motion, it gains some velocity that is equal to 9.8 meter per second. Okay, so after 1 second, that 0 becomes 9.8, means how much oscillation produced? That is 9.8 meter per second square. And if you see that, second and third, okay, and second is initial, that is 9.8 meter per second, and third is final, it is 19.6. So 19.6 minus 9.8 upon 1, okay, second, time is 1 second between this. From 0 to here, it is 2 seconds, okay, but for second and third, it is 1 second, and it will obviously 9.8 meter per second. Okay, if you see here, the first that 0, then at last 39.2, and time is 4. From 0 to here is 4. Then obviously you'll get 9.8 meter per second square. See? So every second you find the same change of velocity. and this is the acceleration of falling body, and it falls, it comes into motion just because of the gravity of Earth, and this is called acceleration due to gravity. And acceleration due to gravity, acceleration produced on a falling body is uniform acceleration. Okay, when there is no any resistance, just like from here, if there is only one force, that is the gravity of the Earth. Gravity of the Earth is pulling, okay, any object from certain height, and when it falls, okay, in its falling body, the oscillation produces uniform acceleration. And when we throw any object upward, okay, class 9, when we throw any object upward, okay, during that time, okay, during that time also the body may have uniform oscillation. But opposite is what? Okay, at the time that oscillation will be negative. Okay, because we are applying the force against the gravity. The body is oscillating against the gravity. The body is going upward. At the time, okay, it may have or it has, uniform oscillation. If there is only one force acting on that, okay, at the time, but the oscillation will be negative. Remember that. Okay, when a body is falling down, okay, for oscillation due to gravity, the G will be positive, right? But when you throw any object upward, then G will be negative. But that is uniform acceleration. Understood? Okay. More I want to go. Sorry. Now, 1 minute. Uniform oscillations and non-uniform oscillations. So you can see some, that is examples there. If a body covers a same displacement, that means equal displacement with the equal interval of time, or you can say with the same velocity, okay, and every second, that is uniform oscillations. But when we see the traffic, okay, in real, especially in town and city, in our areas, again, if it covers in that straight path, and it will have non-uniform acceleration. Okay, if it, see, differs, sometimes 3 meters, sometimes 4 meters, sometimes 7 meters. That means it will have, change in velocity with the non-uniform velocity. At the time, definitely there will be non-uniform acceleration. Okay, at last, some examples of uniform and non-uniform oscillations. You can see. Then we will start our today's topic, okay, which is very important. See some examples of uniform acceleration. Okay, the motion of a freely falling body. Okay, just before we saw example of falling apple, the oscillation produces oscillation due to gravity. Okay, any freely falling body. The freely falling means, that is the body falls only because of one force, gravity. There is no another force. There is no end force against that. If that is falling just by one force, that you are freely falling, okay, that has uniform oscillations, and the G will be positive. But when you throw, and G will be negative. See, there is no any resistance or no any other forces. Okay, if it moves in that uniform, that the oscillations, or let's say equal change in velocity, it has uniform oscillations. But if you see in real, in our practical life, and we can observe, so many objects, they are in motions with non-uniform acceleration. Yeah. Previous slide. Yes, yes, please. Okay, just hold on, please, for a few seconds. Okay. Okay. This one, Karya. Okay. Let's hold for 10 seconds. Slides of uniform acceleration and non-uniform oscillations. Okay, this slide has the definitions of uniform and non-uniform oscillations with some
Yes, sir.
examples.
I was copying the
Okay.
definition, sir.
Yeah. I'll share these slides, okay, at last of this, chapter. After 2-3
Okay,
weeks,
sir.
whole slides I will share. Don't worry about
Okay,
the
sir.
notes. I'll give.
Okay, sir. Okay,
In
sir.
this period, just try to understand, okay, class 9.
Okay, sir.
Okay, I hope all the students of class 9, okay, they have understood, okay, about the topic acceleration. Now let's start. We know class 9 we are reading chapter 2. The name of chapter is force, and till today, okay, we have finished reading these topics which are shown in red color. And today we are going to discuss graphical representation of motion, under which we will read distance time graph and velocity time graph. Today we will try to understand distance time graph. Okay, distance time graph. And the students of class 9, as you are senior students, you know the importance of graph. When we have multiple data, when we have number of data, and if we have to analyze it, okay, if we have to evaluate it, if you have to, study, okay, the big large number of data at the time, for presentations, okay, for demo, or for making the people understand. So how do we present those data? We have special tools. We have special tools, and we read those tools in mathematics. Okay, in compulsory math, in optional maths, we read these tools, and those tools are called graphs. See, so by observing the graph, so we can easily get the idea, okay, about the terms, about the topics, and about even the relation between the quantity. So if you really like to know about the relation between distance and time, actually distance and time relation, what it gives out the result. That means obviously speed by looking the graph and its nature. So what type of graph there is by looking the nature of graph, isn't it? And then by the nature of that plotting the graph, obviously distance time graph and velocity time graph will be the line graph. You have the line graph. So for you it's very easy, though it is new name or new topic for you to understand is the easiest part. Let me go to distance time graph, or let's say graphical representation of motion. So you have here one slide. So you can see on your screen, class 9. Okay, with example in the picture of graph, you can see. Okay, this is the line graph. Okay, and when we have the data that we have collected from the observation, no, you have collected the data of distance covered in a certain time. Okay, when a body is in motion, and you have recorded, okay, the different distances covered in different interval of times, and if you have to represent your diagrammatically, so if you have to show by picture, so that you can see, so in what type of speed the body was moving, or let's say the body was in motion, then we can use a tool called graph. So we can simply say, graph is a pictorial representation of data of observation. And whenever we talk about the distance and time, obviously, okay, the data of distance and time, okay, are shown by the graph called distance and time graph. So by which we also can analyze the speed of a body. Okay, but in the example or in the picture is, okay, you can see there straight line, not a curved line, then a straight line, and that shows that time also increases, and with it distance also increases. Okay, and this graph shows uniform speed. The straight line, when we obtain by plotting the graph between distance and time, if you are shown the graph like this and ask question, okay, class 9 students, okay, by looking this graph, so what can you show about the speed of a moving body, then easily you can say the body has uniform speed, because in the graph you see a straight line, okay, which shows with the covering of time, okay, the distance covering also increases. And let me tell you students, okay, when we read about that graphical representation of motions, or let's say distance time, or velocity time graph as well, so we always have two variables, and those two variables I have been talking, they are distance and time. And in between these two variables, and one is independent variable, that means one does not depend on other, it is independent itself, but another variable depends, okay, and that is called dependent variable. And in this case, that means in distance time graph class 9, time is always independent, okay, no matter whether the body is at rest or in motion. When a body comes into motion, obviously it covers distance, that means it gains distance. When a body is at rest, it does not have, okay, any distance covered. So whether the distance is covered or not, that the time does not stop. Okay, time keeps on changing. So time is always an independent variable, whereas distance is dependent variable, because we express speed in terms of distance and time, and we say that distance covered in unit time in 1 second. So here, okay, in distance time graph, okay, one is independent, and for this time is independent, and another is dependent, that is distance is dependent variable. and let me know how to draw, or let's say how to plot this graph. While constructing the graph, remember please, independent variables should be kept in x-axis horizontally, okay, and dependent variables should be along with the y-axis, that is vertical. That is starting from origin. If you go to right or left horizontally, that is x-axis, okay, and it is to the right, so it is x positive. And then starting from the origin, if it goes up down, that is y-axis, and it has y upward, that means positive y. So time is independent, so it is mentioned, okay, on x-axis horizontally, okay, and then distance is dependent, so it is mentioned on y-axis, okay, that is vertically, right? So distance time graph and velocity time graph. The example shown is distance time graph, so which we will discuss, okay, in slides in detail. Before that, let me show, or let's say class 9, what is meant by distance time graph. And distance time graph is simply the geometrical relationship between the distance and time taken. So by its name, class 9, you can easily understand, please. Okay, then don't get confused, don't get doubt, or don't get scared. By its name, it is clear. The name is distance time graph. And what are the quantities that we mention in the graph? Obviously, distance and time. Okay, and whenever there are distance and time, these two quantities come, that we always can get another quantity, that is speed only. So distance time by name, we can easily say this is the graphical, this is the geometrical representation or relationship between distance covered and the time taken. Understood? Okay. Let's see here, class 9, more about distance time and time graph. Okay, what is a distance time graph in another language? We can say that, okay, distance time graph, by observing it, we can say that how far an object has traveled, okay, or what speed the body has traveled, or easily we can say that. It is a simple line graph. And for the students of class 9, a two plot line graph is not the big deal. It is the easiest to task for you. It is the easiest work for you. If you get data, okay, if you get distance and time and distance and time, then multiple data of distance time, easily you can plot, okay, in your graph, and which gives a line graph. Only the thing that you have to know or get the concept is that, so whenever you get data and plot the graph, then finally what type of graph do you obtain? So if you obtain the graph, line graph, so which is straight, right? Then you have to understand that the body has uniform speed. And if you get the line curved line, okay, the line will be obtained according to the data, and the data of distance and data of time. Okay, distance covered in the respective time. When you plot the graph, finally what type of line do you get? Straight. Okay, that satisfy y equal mx plus c, that is slope, then you can say, yeah, body is moving with the uniform speed. But whenever you get the curve line, you can see in the picture just below, okay, there are two graphs at the right side of that slide, the picture. Below the graph is curve line, and that curve line usually indicates, okay, the body has non-uniform. So plotting the graph between distance and time, when you get data of distance and time, is not a big deal. The main thing that you have to understand or know, okay, or get the concept is that when we get the graph, at the time, what type of graph do you obtain? And according to that, you have to, okay, justify the speed of a body, right? See here. So distance already I discussed. Okay, let me repeat again. On y-axis, we always keep distance data, and in x-axis we keep the data of time. Now let me go to another slide, class 9. After a few slides, I will come back to you. See here, class 9. When we read distance and time graph, let me tell you. Okay, we can get three types of distance and time graph, because distance itself is a scalar quantity, right? So distance and time time always gives what? Scalar quantity, which is speed. So there can be what? Positive speed, right? Not negative speed. So distance will not be negative. Distance will not be zero. Same way, speed cannot be zero. Distance will not be negative. So there are three types of distance and graph. And the first type of graph that we can see about the distance and time graph is this one. When a body is at rest. Now, if I show this type of graph in coming class, without saying anything, then you have to say, the body is at rest. That means body doesn't have speed. That means body has not covered any distance. Isn't it? That means it is not motion. The time is passing. Suppose if you keep one ball on your table, and the right time there is, let's say, 2:20 p.m. and you are trying to keep the record. At 2:20 p.m., at 2:20 p.m. or 2:22 p.m. If you try to measure the distance covered by ball, then you will get zero because body is at rest. So whenever you are shown the graph like this in the question paper, or in the class or anywhere about distance and time graph, you must be able to say that the body is at rest. It has not covered any distance because the line AB slope is zero, because that line AB is parallel to x-axis. Remember, so when we get the line, it is straight, but it is parallel to x-axis. Remember, and when it is parallel to x-axis means its slope is zero. Means now what? The time is increasing, right? The time is changing, but the distance is the same. Means wherever it is, no distance is covered. Though the time is changing, the distance is not changed in the same place. That means body is at rest. So this type of graph says that the body is at rest. That means body has not covered any distance, and means its speed is also zero. Got it? And another, now this is the important graph, please. This is very important graph. See here. And this is the second type of distance and time graph. I already mentioned you there are three types of distance and time graph. One is parallel to axis, so which is at rest. Okay, and the second one is this is uniform speed, for uniform speed. You can say straight line. And we show that increase in time, and with respect to distance also increases. And then you can see that dotted line. Drawn horizontally, that is CA, and another vertical line, dotted line, that is BA or AB. That means these dotted lines, when you draw, it forms a rectangle, and at this point A, you can find the speed. So in this figure, in this graph, the number or let's say value of time and distance are not given. Once in real graph or in the questions, when time like the 2 seconds, 3 seconds, 4 seconds, 5 seconds, it is given like that, and you can easily find the speed at any point on this line. Do you understand? So when you see the line, that has slope, that has slope with the x-axis, and that shows the increase in time and distance increase as well, and you have to say that the body is in uniform speed. I will talk more about this. Just simply know the nature of line. That is obtained by plotting the graph between distance and time. And finally, fourth type is this one. In three types of graph between distance and time, the last type is this one. So it is a curved line. It is not a straight line that starts origin, though it shows that increase in time and even the increase in distance, but there is fluctuations. Not the equal change in the distance in equal interval of time. Sometimes that in the same time, more distance is covered, and in the same time that the less distance is covered. It forms curved line, which is also parabola, right? And when you see such parabola, curved line, bending line, that is the line obtained by the graph of distance and time, and you can easily say that the body is in non-uniform motion, or let's say speed, non-uniform speed. So here is one data. So here, as an example, distance 3 meter covered in 2 seconds, 6 meter in 4 seconds, like that. can see some examples of data, and if you get the data like this, okay, of distance and time, and you can plot the graph, okay, and what type of graph you can obtain here, let me show here. See here the first graph, okay, see here the first picture, okay, that is graph. You can see, you know, yeah, straight line, and obviously it is uniform speed, uniform motion. Now if you like to, okay, measure or find or calculate, okay, the speed at any point here, then you can draw that straight line, okay, horizontally, that is parallel to axis, and vertically, okay, parallel to axis, and wherever they meet that point, and from this you can find the distance, and from x-axis you can find the time, and distance upon time easily gives the speed, okay. Now second picture please, second figure, there you can see three straight lines. All these three straight lines, A, B, and C, okay, say that in all these three conditions, the body is in uniform speed. The body is in uniform motion. In A also, B also, C also, the body is covering equal distance in equal interval of time. But what difference this graph wants to show to you is that during A, the body has more speed. That means the body covers large, amount of distance in same time. If you compare these three straight lines, and C says the body has less speed, it is uniform speed but also less. And if you compare all the three lines, the A line says that the body has, highest speed. So among these three, okay, A, B, and C, in case of A, the body gets the highest speed. So whenever you get the straight line, okay, near to y-axis, when it has high peak, and you can easily see that, so it has more speed. Yeah. And when the C has that, oh yes, it has less speed. Got it, class 9? Okay. Finally, please, for 1 minute, you can see there green line. Okay, green line, which is which kind of speed, class 9? Yeah, it is uniform speed.
Speed.
And blue line, yeah, blue line. What does it show? Yeah, it shows non-uniform speed,
Onion.
because blue line is curve line. Okay, green line is uniform speed, blue line is non-uniform speed. Now let's talk about the red line. And in red line, you can see the multiple lines there. Okay, the first part of the line, it shows uniform speed, right? And the second part, okay, second part where it is written stationary, that is parallel to axis, means now the body is at rest. The body does not cover any distance. Okay, when it reaches to this point from the first part, and it stops there, and the time is changing, and okay, finally now the speed, another line, it shows that speed decreases or it is returning to start point, like that. The main part is that first part, okay, that is uniform speed, and second part is, that is body is at rest. Okay, like this, we came to know a little about distance and time graph. Next week we'll discuss about velocity and time graph. Okay, class 9, I came back to you. Yeah, Pralon, Subham, are you clear about today's topic?
Yes, sir.
Yes, yes, very simple. The simplest topic of this lesson, distance time graph. Yeah, what's about Pralon? Okay, and today I will assign you homework with data. Okay, I'll give data in table, and then you have to draw a graph. Okay, and write the nature of speed. Okay, any questions, class 9? Any questions?
No.
No? Yes, Rhythm, Anushka, Vivek. Oh, Vivek, today I saw you. Okay, I'm so lucky to see you after so long time. Rhythm also. Yeah. For today, okay, this much. Just know today, okay, in online class of science, so we read distance and time graph. What is an distance time graph? Okay, the pictorial representation between distance and time. Okay, and what does it show? Okay, it shows the the speed of a body, like that. Next time I'll say the importance of distance time. Then we'll read velocity and time graph. And for class 9, let me tell you, velocity time graph is important. is more important. We'll practice many questions, okay, about velocity and time. Understood? Ready for that for next class. Okay, so before I say bye bye to you today, okay, let me know that I see only 5 students in video. Where are others? Are they also in this group? So I use mobile. Okay, let me be sure that the slide which I share during the class, is that visible to you clearly or not?
Yes, sir.
Yes.
Visible.
Okay.
Yes,
Yes. Yes.
sir.
Please. Yeah. Yeah. If you get any problem, please. Okay. You can write chat or you can say to me. Then I'll try to improve. Okay. But the thing is that I see only 5, 6 students. Okay, in class 9. Do they come without video or they do not join? You don't have idea. Yeah. Okay. Yes. If you do not have any confusion, if you have any comments or suggestions, you can give. Otherwise, we'll say bye bye to you, and we'll see you in next class. Any comments or anything that you like to add? Yes.
So that you said my camera is my laptop camera is not
Okay.
working, so
Yeah.
I
Okay. Okay.
didn't
Okay.
open.
Yes. Okay. Karya. Yes. Yes. Thank you so much. No matter. I can hear your voice. Okay. So happy to listen to your voice. Yeah. Okay. Then class 9. Okay. Enjoy. I think this is the last period for today, yeah? Okay, Shubham Yadav. Oh, you look so handsome, huh, Samir? Okay, class 9, bye-bye. So have a good day.
Bye,
Have a good
sir.
weekend.
Bye,
Bye-bye. See you
sir.
next
Bye,
time.
bro.
See you next time, okay? Bye-bye.